All right, all week we've been focusing on solving polynomials either through graphing or with the P over Q and synthetic division. So today is where we're really going to put all of that together. So remember that every time we solve a polynomial, we're finding the x-intercepts. So in class, next time I see you, you will be matching polynomials to their graphs by matching up the x-intercepts, which means you're going to get a list of polynomials and you're going to have to find their x-intercepts and figure out which graphs go with that. A big hint to kind of help you to narrow down which polynomials go with which graphs is to look at their degree. Because remember, the degree will tell you the number of x-intercepts that graph should have. I only have one example for you. So I want to know which of these three polynomials, the black one, the red one, or the blue one, matches this graph. So I want to point out first that this graph has x-intercepts at x equals 1, at x equals 0, and at x equals -3. So one of these three polynomials has those three x-intercepts. First, I notice that all three of them have a degree 3 polynomial, which means I can't get rid of one of them just by looking at the degrees. So I'm just going to start with this black problem up here. I have x to the third plus x squared minus 5x minus 2. I'm going to look at factoring first. There's 4 terms, so this would be factor by grouping, but I notice my first 2 terms are just x cubed and x squared, and my second 2 terms are 5x and a 2, so there's no way that I could take out something from each half to make them both look the same. So this is going to be a P over Q problem. So I have my list of P's and Q's. So I know that I have plus or minus 1 and plus or minus 2. So I'm going to start with 1. That's not a remainder of 0, so that doesn't work. So I'm going to start with, then I'm going to do -1. So I have 1, -1, 0, 0, -5, 5, so that's 3, so that doesn't work. So we'll try 2. Alright, so 2 is an x-intercept. So I'm left with x squared plus 3x plus 1. I can't find 2 numbers that multiply to 1 but add to 3, which means I have to use a quadratic formula. So that's -3 plus or minus the square root of 5 all over 2. And I can't simplify that at all, so my 3 x-intercepts is this and x equals 2. These obviously do not match my graph, so I can take number 1 off my list. I'm going to go ahead and delete all of this. So this one does not match. So I'm going to see if this has x-intercepts, the red one, if that has x-intercepts at -3, 0, and 1. Again, it's 4 terms, so I'm going to try factor by grouping. Here, it does look like it will factor. So if I split it in half, I can take an x squared out front to leave me with x plus 3, and then there I can take out a -1, so that's also x plus 3. So I have x squared minus 1 and x plus 3. This x squared minus 1 can still factor to x plus 1 and x minus 1. So when I solve all of these, I have x plus 1 equals 0, x minus 1 equals 0, and x plus 3 equals 0, which gives me my 3 x-intercepts at x equals -1, x equals +1, and x equals -3. Two of my numbers match, but this has 0, my graph has 0, and this does not. So I know that option 2 is not an option either. So I'll get rid of this work. Why does it not go? Okay. So I know the first two do not work. So I'm going to assume that the last one does match this graph. We're going to try it just to make sure. So I have x cubed plus 2x squared minus 3x equals 0. It's a degree 3 polynomial, but I do notice there's only 3 terms, so I'm going to attempt the star method here. So I'm going to take out a GCF first of x. So I have x squared plus 2x minus 3. So I need to find two numbers that will multiply to -3 but add to +2. My two numbers are going to be 3 and -1. So I have x plus 3, and x minus 1. So that leaves me with x equals 0, x plus 3 equals 0, and x minus 1 equals 0, which means my answers are x equals 0, x equals -3, and x equals 1, which does match the x-intercepts on my graph. So that is what you'll be doing next class. There's no try on your own. Just be ready to do this in class.